So today's talk, I'm going to cover the energy and carbon and really bringing it down to the basics as much as possible based on my experience, and also share more about what my company does in a very brief way. But I'll focus more on the questions that are there today. This is the plan, the agenda. Sorry, let's move to the next slide. This is the plan of presentation today. We're going to talk about the whole energy perspective. This is something that I always like to start with in enabling the audience to really get a bigger picture. We're going to look at some key trends and understand some of the trends which are there in the market today. I've borrowed some of the latest reports to take these trend graphs. And my task is really to help you understand so that if you read these reports, you'll be able to read them with the right perspective. We're also going to touch upon a little bit on low carbon technologies, knowing that it's a 1-hour seminar or webinar. I'm not going to go into details of each technology, but I'll touch upon them very briefly. We're also going to look at some interesting topics such as the energy water waste nexus very briefly. And I'll also spend a bit of time on the low carbon energy policies, because that's something that I've had some good experience on or also involved in firsthand. And we'll end with the Singapore Green Plan, which is the hot topic today with everyone. So I'm not going to go into details of that, but I hope that with this understanding of the previous points, you'd be able to get an appreciation of how the Green Plan fits in the overall scheme of things and how it actually is going to help us get to a more sustainable world. Yeah. So if that is all okay, I'm just going to go to the next slides and start my presentation. Before that, I'm just going to switch to the pointer so I can point to the things correctly. Yep. I hope my pointer is also visible to you all. Yep. Okay. So, like I said, I'll start with the whole energy perspective. So again, this is a very simple, simplistic diagram, but to me, it gives a good picture of how we should talk about energy and which are the key elements to talk about. So of course, and I'm also showing this because I'll be using these terms during the presentation. So to start with, number one, primary energy sources. So of course, most of us know by now, they could be divided into two parts. One is the non-renewable sources such as oil and petroleum, natural gas, coal, nuclear. These are all non-renewable. And there are renewable sources of energy such as the sun, solar, water, hydropower, wind, and earth, the geothermal power. So again, like I said, we are not going to details of these technologies. I presume you would know or have some appreciation of them, but we'll be using a reference to them. And that's why I thought it's better to bring it up front. So these are the primary sources. Then the secondary source, of course, are the carriers of energy, which is mainly refined fuel that we use in our cars and also for various industries such as gasoline, diesel, heating oil, propane, etc. Then we have electricity, which is the biggest carrier in most of our lives in terms of the key energy carrier that powers our devices, etc. What is also evolving is hydrogen, another key carrier of energy, and energy storage, which is a very hot topic as well. Again, we are not going to go through details today, but it's good for you to know how you would classify primary and secondary energy sources. And of course, the last thing is the end use of energy, right? So when we look at number 1, 2, we are actually servicing number 3, which is the end use of energy. And that happens in various domains such as the industry, like manufacturing, construction, mining, agriculture, as well as transportation, like the sea transportation, land transportation, air, and also in buildings. All of us are used to buildings, and I think previously Gregors did an excellent presentation on buildings. So again, not too much details, but I'm going to touch upon a little bit on how each of them play a part and how we could relate this all back to the question of carbon, right? So that's I thought of giving this a slide up in the beginning so that we understand the terms clearly when they present themselves during the talk. Okay, so looking at the perspective from a different way, a bit more technological. So I put up all these sources. This is a graph that I borrowed from the report called REN 21, which is a report which is published every year, giving you an update of the latest renewable energy technology trends. So if you are not familiar with this report, I would encourage you to get a hand on it. So I borrowed this one from the 2016 report, where they have presented very nicely how we should look at different energy sources, which I've mentioned here on the x-axis on the top here. And if you like, on the y-axis, there are the various ways of using energy, from the primary energy source to the energy carrier, which we talked about earlier, the conversion type which is involved, the usable energy flow, and the final energy services or the end use. So we looked upon these end use in the previous chart. The reason I'm showing you this slide is to also see how energy gets transferred or transformed into different ways and how it becomes usable at the end. So you'd see that mostly the non-renewables use the thermal conversion route of energy usage. So basically, you would be using the nuclear, fossil fuels, bioenergy to convert it into thermal energy that is produced as heat, and then heat is used for the kinetic conversions through steam turbines or gas turbines, which we then use to produce electricity and work. So this is the primary way how non-renewables are used as an energy generating source. Whereas if you look at renewables, they have a more direct path towards end use, and that's another benefit of renewables, which I find very interesting, is that they reduce the complexity. So not only are renewables good for reducing carbon, but in a way, if you look at this chart and follow this, they're also good for reducing the complexity in terms of the industry. So for example, geothermal energy, you would get directly heat. Heat you could convert to kinetic conversions and make electricity and work out of it. Solar is even better. You can actually directly go into applications such as heat, or you can go into applications such as electricity directly. Right? There are not many conversions involved. Same thing with wind, hydro, ocean. You'll be able to get into electricity and work much faster and quicker, and in a less complicated way. Yeah. So I thought of also showing this slide so that we can get an overview of how things are, how energy sources are being used, and then you can try to think about carbon emitting possibilities in each of them. Of course, the more complicated or the more intricate the process is, there are more opportunities for carbon emission. I'm saying that in a positive way, but essentially it means that you would have more carbon emissions because of the complexities which are involved. Okay, so now I've also borrowed some charts. You'll see that my presentation is going to be a presentation of a few charts which are well known. The reason I'm doing that is to basically also pique your interest on the topic, and also make sure that we understand the points about how energy plays a role and how it should be looked upon from the holistic carbon point of view. Right. So this is a chart showing the global carbon emissions by different sectors, and you will see clearly the blue portion, the energy sector, accounts for 3/4 of the total carbon emissions in the world. The other sectors are the agriculture, forestry, and land use sector, and the industry and the waste. So basically, these sectors are relatively less compared to energy. So the total emission of carbon around the world today is about 50 gigatons of carbon every year, out of which energy accounts for 3/4 of it. About 73% is accounted by the energy industry. And this trend is growing. Again, an interesting chart from the International Energy Agency that I borrowed to see here that this trend is clearly going up. If you look at the past 2-3 decades, this trend has been only increasing. You can see a clear increase in the 90s with industrialization and adoption and data boom, which actually made it grow even faster. And you can see some blips. I hope you can identify the blips are due to the economic activities. So, for example, this is due to the economic downturn that happened earlier towards the end of the last decade. And again, you will see the COVID blip here, which is happening towards the 2020. So let's zoom into that a bit more. And again, got this chart from the IEA to see how COVID actually impacted the global energy trend. So this chart shows 2019 to 2021 comparison, and it is indexed to 2019. So you'll see the relative change in GDP, which is the red line. So you'll see that GDP definitely dropped down, and it's going to be recovered soon by 2021, hopefully. This is the prediction previously. So looking at the current situation, maybe it takes longer. What I find interesting about this is that the energy demand is actually following the same suite or the same trend. But if you look at the carbon emissions, they actually seem to have a more deeper cut in terms of the years where we had COVID. So what that tells us is that not only are we transitioning towards lower carbon emission energy sources, but also the economic activity basically takes a bit of time. And second important point is that there is a lag in terms of how the environment basically looks at or sees the carbon emitting from the energy sources. So that's basically, I thought this is a good thought-provoking slide as well, or a chart as well, to help us think about what is the impact of lower economic downturns, and in this case, the pandemic effect, for example, in reducing the carbon emissions due to energy. This chart is again used by several people. I just want to use this to show that if you look at the theoretical energy capacities around the world, of course, the renewable sources present a much bigger opportunity. So the size of the bubble here shows the theoretical potential that you can have from different forms of renewable energy. Of course, the biggest one is solar. And if you compare that to the remaining, such as the non-renewables, you can see the bubble size is relatively much more smaller. Right. So also it said that the sun's total energy falling through the atmosphere to the earth in 1 year is approximately 4,000 times the current energy that we use over the whole year by the entire mankind, right? So basically, that's how big a resource we have, just that we are not able to use that resource effectively and efficiently to harness our energy needs, right? So basically, that's the paradox that we have. And a lot of thinkers, a lot of scientists have been thinking about that, including some prominent figures as well. This guy is one of them. I'm sure you know who he is. It's Bill Gates. Bill Gates, in one of his TED Talks, mentioned that he is looking for an energy miracle. So he said, if I were allowed to have one wish, I would choose an energy miracle, a new technology that produces energy at half the price of coal with no carbon emissions. So now the question is, this is a good challenge. We have seen that there's a huge abundance of renewable energy, which is available to us. There is also a prominence of renewable energy so far, because of which the carbon emissions have gone up. Is it really possible to have an energy source which can produce energy at half the price and with no carbon emissions? I would say it's not very far-fetched in today's age. The way things have moved over the past decade, it's kind of a good news in terms of that. I think a lot of people are stuck in this paradox, but what I want to show you today is that the latest reports are showing that we're actually inching much closer to this dream of creating an energy miracle. So why do I say that? Firstly, of course, the environmental impacts of different forms of energy are very clear and well documented. So this chart shows the life cycle CO2 emissions, grams of CO2 per kilowatt hour on the x-axis, and the y-axis we have different sources of energy, starting from the non-renewable sources and then the renewable sources, right? So it's clear that definitely the renewable sources that we are aware to today, like water power or hydropower, the geothermal, solar, wind, they are definitely much lower in terms of their carbon emissions. I think this is a no-brainer. We all know about this, right? Then the second aspect that you mentioned was about the cost. So I borrowed this chart from the latest report from a tool called Lazard. They do this trending of the life cycle cost of electricity generation. Or they basically use this term called the levelized cost of electricity, LCOE. And you will see that they have mapped it out nicely for different energy sources, such as the renewable energy, as well as the conventional non-renewable energy. Right. So what you see from here is I've drawn these two lines here just to show the band of non-renewable energy spectrum in terms of their cost. And we see here that the renewable energy sources are already getting very competitive. So if you look at, for example, solar PV on a utility scale, it is actually much cheaper compared to the band of coal, which is here. So if you look at Mr. Gates' proposal or what he challenges us to do, actually we are inching very close to that. We are producing solar PV electricity at a utility scale at almost half the price of coal. Again, this is a band. The reason it's a band because it depends really on the country, the availability of resources, and the location and the availability of the energy transformation as well, right? So, but it's good news that we are actually able to get that. However, there are still renewable energy which is stuck at a very high price, like the solar rooftop residential, which is again getting cheaper as we speak. This chart is from 2020. I think as over years, the new charts are coming up every year. And you will see that the levelized cost in terms of dollars per megawatt hour, or what we are used to, such as the cents per kilowatt hour, is basically becoming more and more competitive for renewable energy when you compare that to the conventional energy sources such as coal, as well as gas and nuclear. So of course, nuclear is a clean energy source. We saw in the previous slide that it has much lower carbon emission potential, but then it's basically losing out because of the nuclear disasters that we had in Fukushima and the worry of people that nuclear can actually impact the safety. And so that's a big concern that is there, because of which the new nuclear sites are actually coming up, and many countries have gone ahead to decommission nuclear energy. But again, you can see that it's still stuck at a very high cost compared to the other renewable energy sources, which have really been over in terms of their cost implications over the past decade. The other thing, of course, to consider is it's not only about the cost, neither it's only about the environmental factors. And that's why people call this term called the energy trilemma. I'm sure you might have heard about it just in some part of your life. The energy trilemma basically talks about the energy security, the energy sustainability, which is the environmental factor, the carbon emissions, and the affordability, which is the cost. So we looked upon the sustainability and the cost in the previous few slides. We didn't talk too much about the energy security. Right? So again, energy security is a big concern, because even if you could get the best source of renewable energy, how do you secure that? Take the case of Singapore. Right? Singapore knows about sources of renewable energy such as solar, which is used now popularly in Singapore, but we don't have the land space. We are land scarce to do that. That's why we are actually drawing up lines all the way up to Australia sometimes. And we have to rely on neighbor countries to basically make sure that we can get our solar panels installed with a large amount of area which is available around us. And today, Singapore is relying on natural gas. 95% of our electricity is produced by natural gas, which is borrowed from Malaysia and Indonesia, or the bought from Malaysia and Indonesia. So energy security plays a key role. And that's one of the reasons that Singapore has gone to invest in liquefied natural gas, for example, so that we can create our own stock of natural gas that we use for powering our industries and for making electricity here locally. But I think that it could be even broader than that, because not only these three items of the trilemma are important, but also the other factors, such as the longer term availability. How good is this energy source in terms of its long-term availability? So if you look at gas and liquefied natural gas improves energy security, it is better on the sustainability front because it has lower emissions compared to coal. It becomes more affordable, but then is it available long-term? So that's a question that we have to ask. Also the reliability. If you look at renewable sources such as solar in Singapore, if there is a big cloud cover, we will have intermittency or variability issues that need to be tackled. If you look at the other factors such as the performance, solar panels actually lose out big time on that because the efficiency of conversion is actually currently very poor for the current technology. Even though it's getting cheaper, the conversion efficiencies are not that great, right? We're talking about around 20% conversion efficiency compared to much higher in the non-renewable sector. Also the power density, which affects the areas such as Singapore quite heavily, because if the power density is huge, like if you can actually store a lot of liquefied natural gas in an amount of space, the same amount of space if it's used for solar panels, you won't be able to generate even 1/10 of the electricity that is required, right? That could be generated by the gas usage. So that's another important factor. The cost we talked about, the geographical availability, right? We spoke about that a bit, about how Singapore could actually be in a very peculiar situation because of that, right? And also the other point about grid compatibility. So again, we are not going to go into details of the grid, electricity grid so much, but how compatible is the generation source to the grid? For example, solar might have compatibility issues because of the variability, and so does other renewable energy sources. And there is a possibility of using other transition fuels such as hydrogen and energy storage precisely to improve the grid compatibility and the reliability of energy sources. So I thought these 7 factors that I mentioned here are also quite important factors in taking a holistic view of how we could apply or how we could evaluate different sources of energy broader than the trilemma, and also look at the practical aspects such as the grid compatibility and the availability of the source and its performance in the specific geography. Yeah, so that basically determines our choice factors of using the different energy sources. The other thing to talk about is the prevalence of grids, right, and electricity access. So this graph basically shows the share of population with access to electricity. It's about 2 years old, but it shows the regions in a nice color-coded diagram. For example, the blue areas are with 100% access to electricity. So you could see the developed countries. Also, Singapore has very good access to electricity, but there are many countries which are very poor. So under 10% access to electricity in some African countries, right? And this pin basically shows top 20 electricity access deficient countries in the world today, right? There is another nice chart around this, which is this one, which shows a bit more progress towards electrifying the rural areas, electrifying farther areas in Africa and so on. So this chart shows on the x-axis the annualized average change. So how has things been improving in terms of electricity access relative to 2010, a decade ago? So of course, you want to be on the right-hand side of the chart so that you can be dramatically increasing your access. And countries such as Kenya, Bangladesh have been able to do that. They've been able to actually really go beyond the world average of year-on-year growth in terms of access to electricity. On the y-axis here, you will see the share of population without access to electricity, right? Sorry, rather with access to electricity. So the higher here, you're better. So definitely you want to be on the top right-hand corner, even if you're a developing country. So here, basically, you'll see many countries which are moving towards that. And unfortunately, you'll see several countries who are stuck to the bottom left corner, which are mostly African countries, and they have very limited access to electricity. So the question now is, how do we treat this information? On one hand, we saw the accessibility, we saw the availability of renewable sources, we see the availability of grid, we saw the important factors which are important for energy sources. And here, on the other hand, we also see the infrastructure which is required. And that's where policy plays a part. That's where the infrastructure elements come in to support and make sure that we are getting the right access to electricity to the wider population as required. Right. So another very interesting chart, I think this one, which shows you that the world average right now is 90%, right? And there are so many countries in the world today which are below that line, and many of them are actually low-income countries. The blue bubbles are the low-income countries, yeah, and whereas the green bubbles are showing the middle-income ones. So again, a very different perspective on looking at energy and electricity availability. If you look at the trends and what's the prediction is there, this is by the Arena, which is another good source of information on renewable energy. So they predict that if we continue business as usual, the top line, we would actually grow our emissions. This is basically showing the gigatons of CO2 emissions per year. And this is back from 2015 up to 2050 to 2015. And they predict that we could have reductions, to a great extent. We could actually go much beyond. We could even halve our carbon emissions or go towards carbon neutrality over time by adopting certain measures. And in this, the key observation is that renewables would account for more than half of the total emission reduction in 2050, with another 45% coming from increased energy efficiency and electrification. So electrification is a key objective or the key track or key infrastructure requirement. And you saw from the previous chart, the electrification rates are so important in terms of the development of the country as well. Right? So electrifying more areas, electrifying more resources, such as, for example, even our vehicles, going to electrical vehicles is important. And increasing the energy efficiency is important. And that's why the earlier talk about green buildings, improving energy efficiency in buildings is of so much importance. So this is a nice picture, shows us how we could move towards a more carbon neutral world over time by taking actions on different fronts, and what could be the contributions of each of them to the overall carbon reduction. This has been what we have been doing so far. So this is the consumption chart. So this is the total global primary energy consumption in terms of different fuels. So you'll see we have been we are weaned off traditional biomass that is burning wood long back. Then we went to coal, then we went to oil, and then we went to gas, and now we are adopting renewables over time. Of course, you can see already a small decrease in coal usage. Oil is still going up. Gas is still going up very strongly. So we are at a point where we are at a transition point towards renewables. This green and blues actually are going to increase over time quite drastically. But this is the current situation today. For us to understand where are we today, we are at almost at the peak, we would say, with the non-renewables preferentially. With coal, you can see already we are crossing the peak. I'll show you more slides to substantiate that. Again, this is another slide from the REN 21, which I thought is good to see. I think I like the fact that we are now looking at the share in the energy end use. So how much of the energy sources are actually used at the end? So this slide is showing the renewable energy usage in terms of the total final energy consumption, TFEC. This is a new term which is evolving around the world, because it's important that to understand that it's not only the electricity, we also need to consider other energy usage, and such as transportation, heat, etc. And they have divided that into three main parts of energy use: the thermal energy use, the transportation use, and the power use, that means producing electricity. And you will see that the share of renewables in each of them is actually not that significant today. So for example, the thermal, we are looking at a small renewable electricity of 10%, small share, and about 5% of non-renewable electricity, but most of it is used by burning other non-renewable sources directly, the thermal processes. Then in transportation, we have again a very small share of renewable electricity, and we're also electrifying our electric vehicles by non-renewable electricity as well. So things are changing in the transportation sector as well, but at a minor scale right now. The power sector is the only sector which has gone ahead with a large integration of renewables. So you'll see that today about 27% of the electricity or power is generated using renewable electricity. Yeah, so that's a good news. So it's good for us to look at the final energy use, how they've been used. The right-hand side of the whole energy perspective that I showed you earlier, that we would have different sectors, and each sector have to be considered separately in terms of the energy use to understand the question as to how we could reduce the carbon emissions in each of them. Moving on, this is another nice chart. Basically, this shows the movement of the energy usage in exajoules, the total energy use, again, the share of total final energy consumption, and how we've actually moved from over the decade, from 2009 to 2019 recently. So over one decade, what has happened in terms of our usage of energy. So you saw the different sectors. If you sum them up all together, we have actually moved not much in terms of the fossil fuel usage overall. We have gone from 80.3 to 80.2% in terms of the fossil fuel usage over a decade. Whereas, of course, the energy usage overall has gone up, right? The economic activity has gone up. So you see that the amount of the height of the bar is definitely higher. So we have gone up in terms of our usage, but in terms of the share of the renewables, it is actually not gone up that drastically. Okay, so the share of fossil fuels in the final energy demand barely changed over 1 decade. Okay, so that's a little bit of bummer in terms of adopting renewable energy sources, but that's how it is right now. Also, this chart again shows the same thing, but in a different way, that we have increased our energy use. The delta that we have created, the total final energy consumption in exajoules, the delta, only 1/4 of that delta is actually service for modern renewables. So we saw that overall the impact is not big, but if you look at the delta itself, how big is the impact? The delta is actually showing that only 25% of the new usage that we had created for energy is currently serviced by modern renewables, whereas 75% is still provided by non-renewable sources and fossil fuels. So we have improved from the 80% to 75% for the new energy usage of the delta, but more things can be done. We can actually improve that much better. In terms of electricity supply, I shared earlier that the electricity or the power sector is the only sector which has gone ahead a bit further in terms of adopting renewable electricity. And here you will see that there is around 27% of renewable electricity, out of which there are different technologies which are providing for. Hydropower is the biggest one. So more than half of that actually come from hydropower within renewables. And then steadily the other power sources such as wind, solar are also getting prominence. Yeah. This is the chart that I shared was referring to earlier. This shows us the share of low carbon sources and coal in the world electricity generation right from 1971. And so over the past few decades, 5 decades, what has been our share of low carbon sources? So this chart primarily shows the low carbon sources here. So you can see that basically that line is moving like this. We had nuclear, which is the yellow portion here. We have other renewables. The renewables is clearly going up. Nuclear has gone down, as you can see, because of the worry that I mentioned earlier. And renewables are actually going up. But 2020 was the first time when the coal source actually went below the low carbon sources. So I think that's quite a significant achievement as well. That is, for the first time, these curves were going to meet, and we knew that it's going to cross at some point of time. That point came in 2020, where the use of coal in terms of generating our electricity went below the low carbon sources, which are the nuclear and other renewable sources. Yeah, so that's a quite significant achievement. And of course, we all hope that this will trend upwards now, that there's no looking back. That means the coal line will not jump back up again, and we will have the blue line of low carbon sources trending up all the time, and coal going down all the time. And that would be the best thing for our environment. Again, another perspective to look at the trends. So what is the share of new capacity additions in each year the past decade? So we have been adding new energy capacities to service our energy growth. I mean, we have newer ways of consuming energy. Now we have blockchain, we have cryptocurrency, we have different sources which actually use much more energy compared to what we were used to in the past. So that new delta of energy needs to be serviced by new capacities. And this chart basically shows the share of new capacity, share of renewables in the new capacity, right? So which are used for generation of electricity. So you will see that the yellow portion here is a renewable share, and the gray portion here is a non-renewable share. So over a decade, definitely we have made much more bigger strides into that. And right now, the new capacity addition, for example, 83% came from renewable energy in 2020. So it's actually trending quite well up in terms of the new capacity additions. So the delta or the new energy uses that we have, more and more of that is coming from renewable sources compared to non-renewables. Again, the investments are also going in the same trend. So you'll see that again, in terms of the new power capacity investments, you'll see that 69% of the new investments are actually coming from renewable energy, and the remaining are from the non-renewable sectors, right? Also, it's encouraging to see that corporates are actually investing into renewable energy through these things called the corporate PPAs or the power purchase agreements. So corporates are actually acting around the world to adopt renewable energy through power purchase agreements. So they see that if they are not in the game of making renewable energy, they are going to be adopters. So companies such as Google, Facebook, Amazon, all of them are basically trending up on the use of renewable electricity through these corporate PPAs or the power purchase agreements. And the global capacity additions are only going up, right? So for example, in 2020, 23.7 gigawatts was added by corporates in terms of their corporate PPAs, renewable energy PPAs or power purchase agreements. So that trend is nicely going up. So I think that's another helpful trend for us in terms of how we could actually move on our carbon reduction through the corporate action. But countries are doing the same. So basically, this chart shows a nice overview of different countries and how they are using renewables. Again, some of you might know this, and it might be good for you to see how different countries are using renewable sources. So, for example, Denmark right now is using very close to 60% of its generation is made from renewables. Whereas if you look at other countries, it's much more than 10%. Right? Singapore is definitely much lower here. We are around 1% by renewables. So over time, of course, everybody wants to be moving towards the high renewable electricity share. But of course, these countries are blessed with more renewable sources, and that's the reason that they are really able to do that. So if you look at the wind and solar power, you'll see that several countries are actually in the top region are blessed with wind, which took a much more rise in terms of the market penetration earlier on in the previous decade compared to solar. That's why you'll see Denmark, Uruguay, Ireland, actually they made very good strides with renewable wind power, reaching up to 40% and beyond in terms of the total share of electricity generation. Whereas most countries you will see are less than 20%. So that's the, if you look at the top 10, they're probably higher than 20, but the other ones are actually much less than 20%. Then I think we look at the grid emission factor, right? So bringing it all back to carbon. So of course, I like this grid emission factor terminology. Some of you might have heard it, but grid emission factor basically measures the average CO2 emissions emitted per unit net electricity generated. So basically, how much of carbon dioxide or carbon emissions or carbon emission equivalent, or such as other greenhouse gases, you are emitting per kilowatt hour of electricity that is produced in the country. Why is it per country? Because then every country has a mix of energy generation. So like Singapore has 95% by gas power today, whereas if you look at China, if you look at Indonesia, the coal percentage would be higher. So this grid emission factor is a very interesting overview of different country and how they basically are transforming their grid and their entire electricity system towards a lower carbon future. So if you look at this trend now, so if you just tag them up together, and if you look at the numbers, there are many countries which are doing close to, actually they used to be close to 1,000 for many countries, but because of the use of gas, moving towards gas, which is much less polluting compared to coal, they're coming to the 800s and 700s region now, except for South Africa, which you see is still using a lot of coal. Whereas many countries are going towards even single digit, right? Very close to single digits. So Sweden and Norway, the grid emission factor is only 12 grams of CO2 per kilowatt hour. Of course, in a carbon neutral world, we want this grid emission factor to be zero, right? So that's the ideal. Singapore is trending around the halfway mark, around 418 as of 2020, right? And we have been also decreasing over time. So I also brought up this to put in perspective the electric vehicles adoption. So oftentimes electric vehicles are considered to be a very good foray into adopting cleaner energy and reducing our carbon emissions. But from now, I think it makes logical sense that the electric vehicle is as green as the grid, right? So how green is your EV? It is as green as your grid, right? So because finally you're going to use electricity from the grid to charge your electric vehicles. So if you charge your electric vehicle and plug it in Sweden or Norway, your EV is going to be very green, right? It's a no-brainer. But if you're charging your electric vehicle in South Africa, your electric vehicle is not that green. In fact, if we could argue that it is actually worse than using traditional fuels such as gasoline or petrol, right? So it's basically worse off in some cases. So I think things have to be put in perspective in many cases, and that's why I brought up this grid emission factor, which is an important element to consider when we are looking at the changes that are happening in the electricity grid and the adoption of transportation options such as the electric vehicles. Okay, this chart just shows us the grid emission factor trend for Singapore. So Singapore has been quite steadily reducing its grid emission factor by moving from oil in the past to gas. And with the liquefied natural gas, we're also increasing our security. But you'll see that clearly the trend is going down. We're also getting more efficient. So that's another factor that plays in terms of the grid emission factor, that the more efficient you are in terms of using the resources, the lower the grid emission factor. So Singapore has been more efficient in its combined cycle gas turbine technology. And because of that, the grid emission factors are going lower. With the adoption of solar and other renewable sources, this emission factor could go even lower. Right. So I think it's a good trend that Singapore is following. Is going down. This scale is a bit inflated, but you can see that there is clearly a drop that is happening over the past decade or the past 2 decades. So we need more, right? So we need more of action around at all fronts. So I believe some of you might recognize this picture. This is the NTU campus where I used to work for almost 8 years. We had covered practically most of the campus by solar panels. So you could see those blue things on the top of the buildings that are all solar panels. And we have put up a huge amount of solar installation, about 5 megawatt of solar installation on the whole campus. But I would want you to guess how much of it was actually covering the total electricity requirement on the campus, right? So we have put 5 megawatt. It was only meeting less than 5%, actually around 3% of the total annual electricity requirement of the campus. And we have to do much more in terms of reducing the requirement itself. Right. So although renewable energy sources are good, you could adopt a lot of solar in Singapore, but we are going to be stuck around that 10% mark, let's say at the most 15% in terms of getting to a good amount of share of renewable electricity. Compared to other countries such as Denmark, if we have to get there, we have to do other things. What are the other things? We have to probably focus on energy efficiency, and that's why the focus on green buildings and other areas is very important. So this chart is again a very interesting chart. I want to spend a little bit of time here. It shows the economic mitigation potential. So we saw earlier that different industries have different carbon emissions and they have a potential to reduce it. So that's shown by this y-axis here, the gigatons of CO2 equivalent per year. But this the x-axis here is very interesting. They're showing the US dollars per ton of CO2 equivalent. That means how much of the dollars you need to do to achieve that. Right, so you want to reduce your carbon emissions in every sector, but at what cost? And what are the opportunities? So you'll see that different sectors have different opportunities. So for example, they have made 3 bands here. The less than 20 means that you are able to achieve it as around less than $2,000 per ton of carbon equivalent in that sector, and less than 50 and less than 100. So you'll see that you want to be higher in the less than 20 band, right? So as much as possible, so that you are able to create major impact in terms of carbon reductions, but at a significantly lower cost, which is less than 20 or less than $2,000 per CO2 equivalent per ton of carbon. So that's what you would like to do. So different industries can be then looked at. For example, energy supply industry, transportation, buildings. You can see is the one industry which is really has the biggest potential. Then other industries, agriculture, forestry, waste. And that's the reason that building industry is often chosen as the biggest frontier for carbon emission reductions, because the biggest bang for the buck, if you like, will come from the building industry. Because not only does it have a big potential to reduce the carbon emissions, but it has a good economic mitigation potential. That means we are able to do that at a much lower cost compared to other sectors. So if you had only limited resource in terms of the financial resources, we would want to put them on the sectors which are going to give you the biggest bang for the buck. And it looks like from this chart, it is going to be the building industry. And of course, there are other industries which are coming close, like the energy supply industry and the industrial sector itself. But buildings actually present a very good opportunity overall. This slide I borrowed from the Rocky Mountain Institute. They have made a very nice resource called, this is done by Amory Lovins, which is a respected figure. I also follow him a lot in terms of his ideas on green architecture and how we could actually go towards a much more greener future with green buildings. This chart basically is coming from his book called Reinventing Fire. I would recommend this book if you have not read it. It's a very interesting book showing you how we could actually go towards a much more carbon efficient world using green buildings. So let me explain this chart. Basically, what he's saying is that if you look at a decade ago demand, and if the demand is to go up, just by on its own, you basically go up from, let's say, 40 quadrillion BTUs to 58, and then you might do something, because definitely you're not just going to do nothing at all, right? So they've done some forecast in terms of energy savings, and we would be basically dropping down to 52, let's say, or 53. So this would be the business as usual energy demand. So this is the business as usual. You want to do more than that, right? So then we will start adopting efficient technologies. So that's basically the big drop which is coming from here. Then we will have smart controls. So I think in the previous talk from Gregors, you would have learned about many efficient technologies that you could use for buildings. There are many companies who are also using a lot of smart controls, AI, IoT, to reduce their carbon footprints, and that's this portion. Then you basically will get to a way that we have used the efficient technologies and controls to come to about 38% savings in buildings, right? And the next frontier, he believes, is going to be integrative design. And that's why what you're learning in the course actually about integrative design is very important, because integrative design really flips the question from technology to a design point of view, right? It's good to have several technologies such as solar, green energy technologies on the building side, more efficient facades, more efficient lighting, aircon, but it's also good to know what element of flexibility we have in the design. So I'm sure that you would have known by now that design actually plays a very crucial role. And according to his quantification, you can get the next frontier, actually much lower reductions, or much better reductions in terms of carbon by using integrative design approaches, right? And he says that you could practically reinvent fire, because you could actually go much lower than the decade ago demand by using these practices, which are the more efficient technologies for buildings, as well as using integrative design. So again, we are not going to details of this topics today, but just thought of giving you an overview of how things are important and which areas are important in terms of a carbon reduction. So buildings definitely are clearly one of them. And design in buildings, better designs, integrative design aspects of buildings are going to be really the next frontiers in terms of carbon emissions. So a lot of buildings are already built today, and we would have tools to reduce emissions in that. But there are also buildings which are going to come up. They are in the design phase today, especially in the developing world, such as in Africa. There are new buildings which are going to come up, which are going to get access to the electricity grid. It's going to be very pertinent to use integrative design concepts there to really achieve a low carbon world. With that, I just want to show a bit of what we are doing, my company is doing in terms of existing buildings. So we actually have this digital built environment ecosystem platform that we're launching on 1st of September. So I just thought of putting a plug on that in terms of how we're reducing the carbon emissions of existing buildings. So I talked about new buildings are clearly the biggest frontier, but we are still having a lot of countries such as Singapore, many developed economies which have a lot of existing buildings which have to be green. The urbanization actually over the last 2 decades has caused many buildings to be there very hastily. We have actually made nice buildings, but they're not so nice on the carbon front, right? So we are actually looking at how we could reduce their emission impact by using a more digital technology, which is AI enabled. So what we're doing is basically to use building physics and AI in a combination of creating a digital twin approach, which also enables digital collaboration. So this platform called Better Life that my company is actually putting up and launching on 1st of September essentially provides an opportunity for collaboration of the industry on the digital front. That means the building owners, facility managers, we would have, let's say, the consultants of buildings, the architects, the technology providers are able to now collaborate and help each other in terms of transmitting the information about their technologies and their know-how in designs on a digital front, and able to design buildings or retrofit existing buildings right from the platform itself, right from the digital platform. And also you'll be able to do technology fit analysis. So for example, which technology fits which building is very important. Recently, there was an article in Straits Times, which was about the fact that there are several technologies which are available today in the world for going green on buildings. You heard about them in the previous talk as well. How are they going to be impactful? How do we assess their impact? And that's exactly what we're trying to solve with this Better Life platform. We're going to create a way for digitally matching technologies with buildings, existing buildings, and able to also do their financial due diligence, so that the cost question also comes into play, and we're able to sort that out. How we are doing that is really to transform the entire physical infrastructure of buildings. So this is the skyline of Singapore. We are transferring drag to a digital map, which is basically going to be allowing anybody, just like a Google map, to have simple models or simple 3D models of buildings, which you can click on. For example, you can click on a building and you're able to see the characteristics of a building, not from the Google map point of view, but from the point of view of energy reduction. So what is the energy use of this building today? What kind of emission factor does it have? What kind of potential does it have? And what kind of technology should it adopt to save energy and carbon in the future? So the question we're asking is, what if you could assess any building anywhere in the world without stepping into one, right? So we are also preparing ourselves for the post-pandemic economy, where it's going to be difficult for us to go into each of these buildings and do the assessment and audits. Whereas on a digital front, we could do this assessment for existing buildings quite quickly using the platforms such as BetterLife. So it allows them to do you a baseline report, for example, like this. You could actually make a baseline report of a building showing you where are you using the energy, in which factor of the energy consumption is there, like lighting or air conditioning or equipment. What is the comparison of the building compared to the city high and city low? And what is the cost of the electricity used today? And also then gives you options to save electricity. Say, for example, it comes up with a quick estimation of energy saving potential with a payback and investment, and shows you which are the attributes that you could improve, and also helps you to connect to technology suppliers who can help you to go towards that plan. So this platform basically is created to be able to have a digital collaboration and know-how sharing and assessments of building anywhere without really going to the building itself, or reducing the manual work and improving the digital accuracy of our models on the platform itself. So I just thought of making that diversion, and then I'll come back to the main story today. Again, this is an interesting chart showing us the vicious carbon cycle. I'm not sure whether some of you are familiar with this. I would like to spend a bit of time here because it is quite relevant to us in Singapore. It is the vicious cycle of energy and carbon, which is linked to a favorite device that we have in Singapore, which is the air conditioning. Right. So we all know that greenhouse gases are increasing our global mean temperature. Definitely, we are feeling warmer because of that. The local ambient temperature is going up, and the need for air conditioning is going up, right? So we need to increase, that will increase our indoor temperature, and basically we need to have more cooling. So if you have more cooling, definitely you would need to, you're going to reject more heat to the ambient because of our air conditioning technology that we have today, and that air conditioning is going to consume power. So the more power you consume, the more greenhouse gas you emit, and the more greenhouse gas you emit, you're adding more to the global mean temperature. So this is the vicious cycle that we have stepped ourselves into, which will, in a way, if you're kind of wondering why even despite the elements of good design and improvements in buildings, why are we keep on increasing our carbon footprints in the buildings domain? Now, some of the answers could be got from here. And you could see very clearly that the air conditioning usage, and similar to this cycle, there are other cycles evolving around topics such as the data centers, for example. We need more data. To get more data, we need more data centers. To have more data centers, we need more air conditioning, more power, and that is going to increase our carbon emissions as well. So these kind of cycles are formed, and they're quite vicious, and we have to figure out a way to come out of them, right? So there are some ways, of course, to make, for example, cooling technology more efficient, to make sure that we have carbon emissions in control all the time, to make better power generation through renewable energy. So there are several elements that you saw earlier in my talk that you can now relate to this. That can help us to come out of this vicious cycle. So if nothing is done, this vicious cycle will just keep on spiraling up and increasing our carbon emissions as well as the global mean temperature. And we are seeing the impact of that already in terms of the forest fires that are happening. The recent IPCC reports that you might have also seen has really given a very dire prediction of where we're heading in terms of the climate impacts. So, and we are responsible for that. We do the use of air conditioning, and the only way to get out of that is to be really more efficient. The question, of course, then the other people would ask is, what if we just capture our carbon, right? So it's much easier said than done. So there are technologies available to do carbon capture and storage. For example, whatever carbon we're emitting from the industrial facilities, we could pipe it down and store it underground, and that could be then even piped out to other places, just like we're doing liquefied natural gas piping and storage. We could actually pipe out our carbon and store it somewhere else. That is possible, but the technologies today are very, very difficult to achieve. These are some of the technologies: the post-combustion CO2 capture, pre-combustion capture, or oxy-combustion. Again, not going into too much details, but these technologies are helping us to actually do carbon capture and storage. And this science is evolving. There are many scientists who are actually focusing on this quite strongly. Very early stage breakthroughs in this is happening right now. But over time, if you're able to do something, you'll be able to also capture the carbon. So this other way to come out of that vicious cycle is we're able to capture the carbon out, right? That we are emitting from our usage of electricity or usage of energy. So that's one way to do that. But right now, none of these options is any superior, or it's still in a very early stage of development, which we really cannot bet on this as a promising technology for the future of reducing carbons. Also, it's important to look at the water energy nexus. As important is energy to us, water is also important. I mean, in Singapore, it's needless to say that we've actually really transformed our water industry. But globally, the usage of electricity in water industry is about 4%. So 4% of all electricity that is produced globally is used for purifying water or making good water for usage. It can be higher in other countries. For example, in the Middle East, it can be as much as 16% in 2040. We're looking at the trends which are going up. So 16% of the energy that they will generate in the Middle East will be used just for purifying water. And so that's a huge percentage. Definitely, if we cannot ignore water industry. Also on the other side, when we in the industry, when we have impure water coming out, there's a lot of electricity which is spent for treating the wastewater. About 8% of the electricity today in the world is used for treating wastewater. And that's a big consumption as well. Right? So we're not only making pure water, but also treating wastewater consumes electricity. That's why integrating water into the climate policy is key in achieving the longer-term sustainable economic growth. Right. So we saw earlier that we didn't feature water industry anywhere in our chart of carbon emissions, but they're integrally linked to energy because it's a huge consumer of energy as well, the water industry. And so is waste, right? Waste is also responsible for a large amount of carbon emissions. This chart I bought from Unomia, it actually gives a very nice overview of what we could do in terms of our waste reduction. So we are used to residual waste treatment in most places such as incineration and landfill. In Singapore, we incinerate all of our waste. It goes to the Semakau landfill. And you will see that the carbon emissions are not that fantastic, right? So we would actually have net positive impact on carbon emissions because of that, because some of it is actually used for our electricity production also. That's why incineration gives you some benefits compared to landfill. But then there are bigger opportunities in many industries such as aluminium and textiles, for example, where you can actually get much bigger impacts in terms of carbon reduction by recycling and composting, right? Especially in the food industry as well. Then avoided production. So if you could avoid any waste at all, the carbon emission impacts could actually really double up and triple up in many industries such as aluminium, textiles. So we know there is a big consciousness going up on the fashion industry in terms of how unsustainable they are in terms of their wastage on the textiles. So if that could be improved, basically our carbon emissions reduction could be quite huge from those industries. I'm not an expert in circular economy, but again, you will see several talks on circular economy going today. And I thought this, just showing it up as a good framework. I've recognized that as an excellent framework for looking at holistically the waste issue and looking at how we could actually reduce our environmental impact by even profiting from it, by generating income, by recycling, making it more cleaner, and extending to better services, and basically completing that cycle and using less and less over time as we go through that cycle. So the circular economy is a big topic on its own to cover, so I'm not going to cover it here. But essentially, that's where we are moving to in terms of kind of a holistic perspective of waste management. So I just want to sum up with the last segment on policy. So I just thought of summing it up from how I bring to my experience in terms of energy, right? So just to summarize, the energy usage is also in different domains. So for example, utility providers have a different way of looking at renewable energy. So even if you look at low carbon energy sources, the consumers such as us or the retail outlets, they actually have a very different way of looking at energy, renewable energy, compared to the utility providers and compared to other industry sectors, right? So for example, renewable energy generation centrally is more relevant to utility sectors, such as the hydropower. You can feature it quite nicely there, solar PV farms, wind turbines. So those have already gone to a very low carbon emission realm. So that's why today your grid emission factor has reduced quite drastically in several parts of the world, and utility providers have not much excuse in terms of carbon emission reduction. Where we need to focus on is really in the bottom sectors, such as the distributed energy generation, which is a sector where we use, let's say, rooftop solar panels, solar hot water heaters, micro turbines, ground source heat pumps. There, basically, there's a lot of work that can be done in terms of carbon reduction, and also in the energy efficiency front that I mentioned earlier. So how do you improve industry energy efficiency, low carbon transportation options, green buildings? So that's a front that we still need to cover in terms of reducing the overall carbon impact, right? The reason I'm showing this is because when you talk about energy policy, you need to consider for whom the policy should be designed. So is the policy designed for utility providers, or is the policy designed for industrial sectors, or is the policy designed for consumer firms, right? So for example, the carbon tax policy in Singapore is very much designed towards the utility providers and industrial sectors, and not so directly relevant to consumers, except that the fact that the cost might be passed on later on, right? But right now it impacts the utility and the industrial sectors much more than the rest. right? So if you look at the policy frameworks, they have to really look at, investigate which usage sector are we targeting, and based on that, determine what kind of policies which are there. So I just want to quickly cover the policy elements that we talked about. Of course, there are many barriers to a low carbon world, such as the high cost, institutional barriers, technology barriers, human barriers, and market failures. And the purpose of designing a good renewable energy policy is to really overcome these barriers, right? It's very logical. So I put this up in this spinner. Basically, the 5 low carbon policy instruments that often are used around the world today, such as regulation and standards, quantity instruments, price instruments, reverse auctions, and public procurement. So very briefly, I'm going to cover them before we end today's talk. So regulation standards are basically something which are promoting low carbon technologies by increasing the attractiveness of technologies related to the other options. Basically saying that now it is mandated, it is regulatory in the regulatory world to actually use certain technology. For example, renewable energy mandates. Like many countries have now renewable energy mandates, and you must adopt certain amount of renewable energy by a certain time. It's about 2030. In Germany, there is a phase out of petrol cars. There's a phase out of other generation sources as well by 2030 in favor of electric cars. So these are really a policy element which is fully in control of the government, but it has to be also used wisely, because if it's too strict, then you will hamper the economic growth sometimes. In Singapore, we have the regulation standards around, it's the building designs, good building designs. There is a code for environmental sustainability of buildings from the BCA, the Building Construction Authority, and it sets out the minimum environmental standard for that any building in Singapore has to use. For example, what should be the minimum cooling efficiency that one has to use in Singapore when you're making a new building, right? So these standards are important because they will really put you give the minimum benchmark for you to improve upon. Also, there are mandatory energy labeling schemes, so you're now able to see this kind of 4-tick or 5-tick devices such as air conditioning and many other electrical equipment. You're able to see this, and that's one of the good instruments of regulation and standards. I'm going to skip this slide. So quantity instruments are basically market instruments which are targeting a specific quantity. So in Singapore, we don't have a lot of them, but essentially these are things such as the portfolio targets, renewable energy certificates. So these basically show you that REC, for example, is a proof that 1 megawatt hour of electricity was generated by using renewable energy sources, and this could be then traded. So this becomes a quantity instrument to ascertain to you how much of renewable energy have you generated and how much of it can be traded. How much of that you can trade. So that becomes a nice quantity instrument to improve your low carbon usage. There are also other things such as the price instruments, for example, feed-in tariff. So you could actually incentivize the price or make the price of low carbon technologies much better. So you could reduce the cost and price related barriers by establishing favorable pricing regimes for low carbon technologies. So in Singapore today, we don't have a FIT or a feed-in tariff. If you produce electricity, you are able to give it back to the grid, but not at a feed-in tariff. In many countries, feed-in tariffs were popular, and they've been slowly been regressed down to in favor of other instruments such as the reverse auctions. So this explains the feed-in tariff. Basically, you produce electricity. There are many examples. I had a colleague when I was in NTU who actually was of France. He was from France, and he was able to generate solar electricity from his home. And basically that covered more than his rental. So he was not renting out his property because the feed-in tariff that he got from the government was much better than the rental rates. So he had put nice solar panels on his rooftop and was able to get good feed-in tariff by supplying that electricity back to the grid. But again, governments have been very cautious in doing this, because if you overdo this, then you create a spoiled market which is not really ready on its own to adopt low carbon sources. Carbon tax is another good mechanism. So in Singapore, we have introduced a $5 carbon tax, and it will be progressively revised to see how we could make it better. So this is another good price instrument to deter the consumption of, let's say, high carbon or non-renewable sources, which contribute to much more carbon pollution. Reverse auction is another mechanism where government could use it as a tool to ask for bidding, and this could be bidded in the open market. Doesn't happen in Singapore. The case in India was, they had this mission where they could use reverse auction as a great mechanism to get reverse bids on solar utility plants. Because of that, they could actually got much lower. It's a good price discovery mechanism to find out what is the best price of finding your PPA, the power purchase agreement.